what I'm going to do here, I need to find the area of the quadrilateral PQRS. And the easiest way to do that is going to be to take this rectangle and subtract these 4 triangles. And that will leave me with the area of this quadrilateral, because I'm not sure what shape quadrilateral that one is. So first of all, in order to find the length, obviously I can see that the area of the outside rectangle, so the area of the rectangle, is just going to be 10 times 8, which is 80 centimeters squared. So that's relatively easy. Let's have a look at the triangles then. Now, the height of this triangle here is x, and the length of it is going to be the distance from here to here. Now, I know that it's 10 centimeters all the way across from here to here. So if that's 10 centimeters, then this bit here must just be 10 minus x. And if I want then to find the area of that triangle, well, the area then is going to be the base times the height divided by 2. So let's take the 10 minus x to be the base, x to be the height. So in other words, the base times the height is going to be x multiplied by 10 minus x, and that's going to be divided by 2. Now if I look at this just by symmetry, this is exactly the same. I've got 10 minus x here. So in other words, we've got the same triangle here, and the area again is going to be x times 10 minus x divided by 2. I'm going to do a similar thing here with these 2 triangles. This length from here to here is just going to be 8 take away x, which means that the area of this triangle is again base times height, so 8 minus x, and that's again divided by 2. And the area of this triangle over here similarly is going to be x times 8 minus x, and that's divided by 2. So if I want to find the area of the shaded quadrilateral, so the area of PQRS is going to be the area of my rectangle. Well, that's 80. And now let's have a look at what's going to happen here. If I add together, so let's add together these 2. So these 2 triangles here, if I add those together, I've got half of x times 8 minus x and another half of x times 8 minus x. So those 2 smaller triangles together, if we add their 2 areas together, are just going to be x times 8 minus x. I'm going to write it properly over here though. So basically I'm going to do x times 8 minus x divided by 2 plus another x times 8 minus x divided by 2. And then I've also got 2 lots of the other triangle. Well, that's 2 times x times 10 minus x. Again, that was divided by 2. So what's going to happen here is I'm going to end up doing 8 minus, now if I do these 2, add these 2 together, obviously I've just got x times 8 minus x. And if I cancel the 2's here as well, I'm going to have x times 10 minus x. And if I keep simplifying, that's going to be 8 minus, if I remove the brackets, I've got inside this big square bracket 8x minus x squared plus 10x minus x squared, and that's the same as 80 minus, if I just simplify inside the bracket, 8x plus 10x, well that's 18x minus 2x squared, and that's just the same as 80 minus 18x but plus 2x squared. Okay, so let's have a look at where this equation comes from. We know, where are we? Oh, that the area, okay, so sorry, this is it then. So the area then, that's all we had to do there, is just going to, if I just change the order, 2x squared minus 18x plus 80. So that's the answer to the first bit. Okay, question now asks us to find dA by dx. And even if you haven't managed to do part A, you can still do this. dA by dx then is simply going to be, so we multiply the 2 times the 2, so that gives us 4x, power reduces by 1, and that just comes out as minus 18. Now, when it says find the value of x for which a is a minimum, it's a bit like finding the minimum point on a graph. If you want to find the minimum point or the maximum, you find dA by dx and then put that equal to 0. In other words, I'm going to take my 4x minus 18 and I'm going to put that equal to 0, and then I'm going to solve it. So 4x is equal to 18, which means that x is equal to 18 over 4, well that's 9 over 2. In other words, that's 4.5 So the value of x for which a is a minimum is just 4 points. There are two different ways to prove that a is a minimum for this value of x. One of the ways is to differentiate again and find d2a by dx squared. Well, for our 4x minus 18, if we differentiate again, we get 4. Now remember, if your second derivative is positive, and in this case that's what we've got, that would imply that what you've actually got is a minimum. So that would be one proof. Another way is to think what the graph of a equals 2x squared minus 18x plus 80 looks like. Actually, I don't really need axes. I've got a parabola, and because I've got a positive number of x squares, I know that it's going to be a happy shaped parabola, and if you've got a happy shaped parabola, it must have a minimum.